Hello everyone, how are you doing? In this video is going to be a short video, I'm hoping, regarding evaluating definite integral, which some of these integral are extremely difficult to use the techniques that we have learned to evaluate it. Therefore, we have no other option to use some kind of a technique which doesn't give us the exact value of definite integral, but at least it's going to approximate it in the neighborhood. And that method called numerical. And we talk about the numerical, which has two methods, trapezoid rules. We talking about trapezoid yesterday on the previous video. And what we did, we took the area under the curve and we split them into, instead of a rectangle, to a trapezoid. And that as long as that delta x was very small, that curve become a line segment, and probably about 2 or 3 trapezoid, you can estimate the area under the curve. And the beauty about that one was that you don't have to do 1,000 of them like a rectangle, which we do at right corner, left corner, or the midpoint. Here with 5 or 6 or 10, you can get your answer pretty much close to the exact. And the formula was that we take from A to B, which is B minus A, divided it into n trapezoid, and then we find the volume, the area of that trapezoid, which is base, lower base plus the higher base divided by 2. Then you do the next one, plus this is y1, this is y2, but remember, this y1 only belongs to the one trapezoid to his left, because we don't have a trapezoid to the right, but we don't have a trapezoid to the left. But this wall, which is your y2, belong to 2 houses, the house to the left, the house to the right, belong to the trapezoid to the left, trapezoid to the right. Therefore, the y2 going to count twice, and this is your y3 now. Therefore, if this is the last trapezoid, y3 going to repeat once, but it is going to be another trapezoid. Y3 also belong to 2 houses, to the one to the left and then to the right. Therefore, y3 plus y4 over 2, and that was the formula. But all of them have 2 as a common denominator, and that's where the 2 came from in trapezoid. And then you have y1. But remember, the wall between the 2 trapezoid, once is counted for the left house, one counted for the second house. And then if this is the last house, but if it's not, y3 gonna count twice, maybe y4 count twice. But if the y5 only has 1 house, which is 1 house and no house is to his right, you're going to count it once. And that was the formula to approximate using trapezoid rules. But today I'm going to introduce something else, which maybe if the trapezoid can take care of it with 6, this one maybe take care of it with 2. Therefore, if you want to find area under that curve, I shouldn't make that curve so simple. If you want to make the area under that curve right here, I can either change it to trapezoid, or I can come back right here and find that midpoint and go same distance to the right or the left and draw a parabola that passes through these 3 points. And parabola passes through a point. My parabola really didn't come, looks very nice. Let me go ahead and change it and say this is the midpoint. I pick that one and I pick that one. Therefore, I'm going to use that parabola to find the area under that curve for that function f of x. And I'm going to find that area under the curve right here, which is the area under the parabola instead of that function. But somebody going to ask you that, well, this was not part of your area. This is above the graph of the function x. But remember, this is below, and this one parabola didn't cover it. Therefore, this piece and this piece, they're going to offset each other. Therefore, we can use parabola to go ahead and find the area under the curve. Therefore, if this is the graph of your sine, see, I can do one parabola here, and then I can do another parabola here, and area under those parabola gonna give me, when I'm talking about parabola, is from here to here, from here to here. You're not gonna bring it down all the way, and you can find the area under the curve. But somebody said, well, what happened if my curve is like this? Well, I need 3 points, and that 3 points in this piece, you're gonna graph a parabola right here. We go through these 3 points, and this is my parabola, which is covered this one and that one. And see, this one is above, and see, this is not part of your under curve, but parabola cover it, but this is the below, and they're gonna offset each other. Okay, let's see what is the formula for that process, and that one called Simpson's rule, and that is numerical approach. Okay, let's say this is your graph, f of x, and I want to find the area under that curve from here to here, and I want to know what is that area. Well, instead of finding the area under that curve, I'm going to find the area under this parabola right here, which is a lot easier function than that function right here. And remember, parabola gonna give you that piece extra because that is not part of the area under the curve, but it gonna lose this one. Okay, therefore, every time you do have a parabola, remember one thing, the parabola is gonna divide your region into what? 2 regions. Therefore, from now on, you have to know on a Simpson's rules, n has to become even. You cannot have n equal to 3, and then you only on the other piece, you take half of the parabola. No, you cannot do that. It had to be the whole parabola. Therefore, n has to be either 2, or n has to be 4, or n has to be 6. Therefore, on Simpson's rule, n must be positive, and tell me what is my formula. Okay, I'm gonna make it very simple. The middle of my parabola, I'm gonna align it with the y-axis, and this one would become your x-axis, and I'm gonna say this is my a, this is my b. That's your lower limit, and that's my upper limit. Instead of doing f of x dx, I'm gonna approximate that one and use the parabola from a to b. But what is the equation of a parabola? The most complex equation parabola I have is ax squared plus bx plus c dx. Therefore, instead of finding the area under the curve of the black one, which the function might be, I don't know, sine of a square root of x dx, I'm gonna do under this parabola from a to b. But remember, it depends what the position of a parabola is. Then parabola in a different position, you're gonna have a different what? Different equation, because the vertex changes and the wideness changes, and how wide is open, how narrow it is, how tall it is, and all of them depend to this a, b, and c. Therefore, every parabola pretty much are having same equation, except they have different constant multiples, which are a and a b and a c. The coefficient of a leading variable, the coefficient of the linear variable, and the constant. How do we find those? Okay, remember I call this one lower limit a to b. There is a here, there is a b here, but also I call the coefficient of the leading variables and the linear variables a, b. I'm going to change those a to b right here. Instead of going from a to b, I'm going to call this one an h, and this distance is going to be h, and this distance is going to be h. But because it's to the left, I'm going to say my a is located at a negative h, and my b is located at a plus h, and this middle is on the origin, is located at 0, 0, and the left bound, when I substitute into the function, it's going to give you some y value. I'm going to call it y1. The middle one, I'm going to call it a y2, and this one is going to call it a y3. Then, if I call this one y1, y2, y3, what is the equation of a parabola in general form? That's the equation in parabola in general form. Therefore, I have f of x equal to ax squared plus bx plus c. Then, if I replace negative h for x, it's going to give me an equation. And that's a negative h squared plus b times negative h plus c. If I put 0 here, it also gives me another value. If I put h in here, it's going to give me another value for y. And remember, I call this left f of negative h. This is your y1. F of negative h is your y1. Therefore, I call this one a y1, just for simplicity. And this one, which is f of 0, I call it a y2. And this one, which is f of h, I'm going to call it a y3. I have 3 equations here. And all of these 3 equations are depend to y1 and y2 and y3. And from these 3 equations, I want to solve 3 variables, a, b, c. Therefore, automatically I know this is 0, this is 0, your c is y2. Therefore, your constant always corresponds to the middle wall. Somebody said, okay, how about the a and a b? What is the first one? The first one is y1, which is ah squared plus minus a bh plus a c. What is the last one? y3 equal to ah squared plus a bh plus a c. I already know my c is y2. But if I add these 2 functions by using system of equation, elimination and addition, I can say y1, your c is y2, bring it to other side. That gives me exactly ah squared. This is y2. Bring it to this side. It becomes y3 minus y2 equal to ah squared. I have 2 equations, and I'm going to add them together, and I'm going to solve for a. I have 2ah squared equal to y1 minus a y2. I have y2, 2 of them, 2y2 plus a y3 over nothing. That's it. But if I divided it by 2a squared, I got my a. Okay. Then so far I got my a and I got my c. What was my c? My c was y squared. And what was my a? My a was y1 minus 2y2 plus y3. See, y2 is a middle wall. Therefore, I had y1 minus 2y2 plus a y3 over 2h squared. All I need, go to one of these 3 equations and solve for my b. I'm going to take that one right here, and I'm going to solve for b. I know c is y2. Bring it to this side, it becomes negative. Therefore, I'm going to have y3 minus a y2 equal to. What do I have right here? I have a h squared plus a bh. I do know what h is. H is my delta x. But I know what my a is. Therefore, I'm going to replace it, and I'm going to say y3 minus a y2 equal to, what is my a? y1 minus 2y2 plus a y3 over 2h squared. Then I have another h squared here, and see, this cancel out. Plus a bh. Right now I can solve my b. But remember, I have 2 right here. I'm going to multiply everything by 2 to get rid of that 2. It becomes 2y cubed minus 2y squared equal to y1 minus 2y2 plus a y3 equal minus plus 2bh. I want to solve for bh. 2bh is equal to 2y3 minus a 2y2, take the y1 to other side, take the y2 to other side, take the y3 to other side, and this is, and cancel out 2y3 and 1y3 is a y3 and minus a y1 over 2h, that give you a b. Okay, you do see my c and a and my b, all of them depend on what? On y1, y2, y3. Okay, I know my coefficient. Let's go find the area under the curve. How do you find area under that curve? You take this one right here and integrate it. And what is the integral of ax squared plus bx plus c dx? I'm not going to replace abc by the quantity we just found, but I'm going to evaluate it from negative h to h, and this is nothing except ax cubed over a 3 plus bx squared over a 2 plus a cx from a negative h to h. I'm going to substitute it, and that gives you the area under the curve, but it's approximate. And that area under what curve? The black one, which was hard to integrate. Okay, I'm using parabola instead though. I'm going to put h in here. I have ah cubed over a 3 plus bh squared over a 2 plus ch minus. Put the negative h. What is negative h cubed? Is negative ah cubed over a 3. Put the negative h in here. When you square it, become a positive. And put negative h is negative ch. When I apply the negative by inside, negative times negative is positive. These two quantities become exactly the same. I have 2ah cubed over a 3. This is positive. Negative times positive is negative. Therefore, these two cancel out. Negative times negative is positive. A ch plus another ch is 2ch. That's my area. And somebody said, what is A? I know what A is. That was my A. What was my C? My C was y2. Therefore, my area is 2 times left wall minus 2, the middle wall, plus the right wall, over 3, and over 2, h squared. That was your A. The 2 is gone. Then I have in here h cubed over 3 plus 2, your C was y2h. Then that one is, what is h cubed over h squared? H over a 3 times y1 minus 2y2 plus a y3. But this is 2. I factored 3 out. What number divided by 3 is a 2? Is 6. I pull the h out. You only have y2 left. You see where that 6 came from? 6 over 3 is 2. Therefore, I need help. What is this? Left wall, 4 of the middle wall, and the right wall. That's your area. Right now, go to your function. I bet you if your lower limit is a, the upper limit is b, like a is 1 and b is 3. What is the middle of it? 2. Whatever your function is, I don't know what it is, you can find f of 1. You can find 4 times f of 2. And you can find f of 3. And your h is your delta x. How do you find your x? Remember, that was your parabola. And you call this one an h, this one an h. This one was your lower limit, this one your upper limit. You see b minus a over 2. Therefore, your h is b minus a over 2. Okay, I got you. I have no issue. But what happens if I have 2 parabola? Make this one b minus a over 4. What happens if you have 3 parabola? B minus a over 6. Therefore, that number n always have to become an even number. Therefore, instead of the h, I'm going to put b minus a, and I'm going to put 3 here. And instead of splitting my lower limit, the distance between lower and upper, into 2, I can do it into n pieces. And I'm going to put the n. And I'm going to write left wall, 4 of the middle wall, and 1 of the end wall. Somebody said, what happens if you have more than 1 parabola, one after each other? These and these and these. Well, these parabola have to be cut in half. Do you see how your end right now is 6, 1. Here is your 1, and that's I'm not gonna call it a name right here. This is my A, and this one is your B. See, 1, 2, 3, 4, 5, 6. You cannot have 5, because if you make it a 5, you do not consider the last parabola as whole parabola. No, you have to use the whole parabola. Therefore, this is your left wall. This is the middle wall. This is middle wall of the first parabola. That's the wall between. Middle wall, the wall between. Middle wall, the wall between. I'm sorry, that's the last one. This one only uses once because there is no parabola in here. The middle wall uses 4 times. This one, if it's 1 parabola, uses once. But because 1 time you count for this one, 1 count for that one, that's become a 2. This is the middle wall, is 4. This y is for the left and the right is 2. The middle one is a 4. The last one, there is only 1. That is the formula for the Simpson's rules. Do you see that number 1, 4, 2, 4, 2, 4, and a 1? Remember, always the end is 1, but come after 4. Therefore, the second from the last and second from the first is always 4. It cannot be 2. Then you take that formula and multiply by b minus a over 3. That 3 came from the common denominators, which we got it right here. That 3 came from h cubed over 3. And n is the number of a trapezoid. This is called area approximated by the Simpson's rules. Okay, let's do an example. But I'm going to make my example easy that I can compute it. I'm going to make my ugly function x cubed plus 2x. Just because I want it to able have a technique that I can check my work. I'm going to make my n to become 2. And I'm going to use Simpson's rules. Simpson's rules, it has parabola. And this is already n2. Therefore, I'm going to go back right here and make my n4 with 2 parabola. Maybe I get closer to the exact. Therefore, what is my formula, please? If it's 4 of them, you're going to have a left wall, the middle wall, the between wall, the middle wall, and the end wall. The end is going to count once, the middle is 4, and the between is 2, and a 4 and a 1. You add, and you multiply by b minus a over 3n. That's Simpson's rules. Give me, what do you want to do? I want to find the area under the curve for this one from 0 to 4. Okay, 0 to 4. This is your 0. This is your 4. Where's the middle of it? 2. Where's the middle of 0 and 2? 1. Where's the middle of 2 and 4? 3. Therefore, this one, I go to my function, which is your y1. Y is the same as f of x. I need f of 0. 4 times f of 1. Because remember, that's your x value right here. I need 2 times f of 2, because I split them, plus 4 times f of 3. This is called 3, and that gives you the y value. Therefore, these are x equal to 2, x equal to 3, x equal to 4, and x equal to 0. And for every one of them, delta x is 1. 1, 1, 1, 1. Okay, left wall, between, left wall, middle wall, between, middle wall, I don't have the end wall. And I said b minus a, n was 4, 3 times 4. And 4 minus 0 is 4, 4 over 4 is 1, you have 1/3. Put 0 right here, I get 0. Put 1 in here, 1 and 2 is 3. Put 3 in here, 27 plus 6. Put 3 in here, 20, let me make sure I did it right. Let me see I make it right. Sorry, 0 is 0, 1 is 3, that's supposed to be 2, 2 cubed is 8, 2 times 2 is 4, that's make it a 12. Then I need a 3, 27 plus 6 is 33. Then I need a 4. 4 cubed, 4 times 4 is 16 times 4 is 64. 64 plus 8, 72. 12 plus 24 is 36. 36 and 72 is 108, because 108. 4 times 30 is 132. 4 times 30 is 112, 12. That's 10, 4, that's 240. And what is 240 divided by 3? 120. Area under that curve of that function from 0 to 4 approximately is 120 units square. I'm going to use my calculator. I'm going to say, okay, I have x cubed. Oh, as a matter of fact, x cubed for us 2x is right there. I'm going to go to y variable. No, I don't need that. I need to math number 9 from 1 through 4. Not 1. I thought that was 0. 0 to 4. And this one came from y1, x cubed plus 2x. Therefore, in here I go to my variable and paste the y1, respect to x, and I'm going to press enter. I got 80. Here I got 120. Something is not right. 1, 2, 3, 4. 3 times 4 is 12. And 4 over 12 is 1/3. Let me see if I made a mistake right here. My y1 is x cubed plus 2x. Okay. Therefore, I'm going to go in here and I'm going to go to variables, y variables, function y1, and I'm going to put 0 right here. Then I'm going to put plus 4 times variables function, and I'm going to press 1 in here. Plus 2 variables, y variables function, and I'm going to put 2 right here. Then the next one is 4. 1, 4, 2, 4. 4 variables function and a 3. Plus 4. I go to variables, y variables function, and a 4. That gives you 240. We got it right. And my n was 4. 1, 2, 3, 4. 3n, 3, 4, 12. 4 minus 0. Divided this one by 12 times 4. Nope. 240 times 4 divided by 12, it give me 80. Okay, let me see what did 240 was right. Oh, then what did I do wrong? 240 divided by 3 is 80. How did I get 120? That's 80. 240 divided by 3 is 80. And what was, man, I've been making a mistake. And what was my answer? The exact answers. Math, 9, 0 to 4, variables, y variables, function, respect to x. Look at what the numerical said. Exactly same thing. I cannot believe with only 2 parabola, I could approximately evaluate the area under the curve of a complicated function by using a simple parabola. Simpson's rules.